Good evening. Can someone confirm if I'm audible?
Yes, you are audible.
Okay, thank you so much. So we had a very long weekend, and I hope that most of you are able to go through the notes that I had shared and also the recordings. And before maybe we proceed to what we are supposed to cover today, we can have a recap of what we did on Thursday last week. And I would like to pick someone just to remind us that is, I think, Belinda. Belinda, in case you're in a position to speak, you can just remind us what we covered last week and especially on Thursday. Okay, sorry for that. Hein, Van, are you in a position to speak?
Yes, yes, I can speak.
Okay, thank you.
All right. So last week we covered basic basics of data science, what it is, and then the types of data that you get, which is traditional data or big data. And we then went into what pre-processing is and the common methods within that, such as class labeling, balancing, data shuffling, etc. We then moved on to where data comes from and where traditional data comes from. Is from SQL and can be basic customer records, IDs, stuff like that. Historical data, while big data is data that cannot be stored on one server. It has massive volume and is stored across multiple servers. Um, we covered who handles data and the different roles in there, such as data architect versus database administrator, data engineer, etc. We then also covered business intelligence, what that consists of, and the different roles in that. And then we just pointing my notes. We then went into the classifications of business analytics, and um, we ended on Thursday with predicting the future and predictive analysis, where we covered traditional methods in predictive analysis, such as linear regression, clustering, factor analysis, and time series, as well as that some of those can feed into machine learning for more data.
Okay, thank you so much for taking us through what we learned last week. And maybe before I skim through quickly, I just want to ask one question to Jojo Mondi. George, can you confirm if you're in a position to speak? Can you hear me, George? Okay, maybe I can pick another person. That's Collins Onteri. Collins, if you're in a position to speak, what distinguishes the traditional statisticians from a data scientist?
Good evening, everyone. I think a data scientist has the abilities to use predictive methods, which are both machine learning and everything that is sophisticated in between. to analyze the data and come up with a conclusion based on the data given, whereas a statistician is a person that can basically use the basic tools of analysis, such as Excel, to analyze a given data.
Okay, thank you, Collins, for your trial. It is a good trial, but the last statement, I think, because Excel has really improved. Like nowadays, we have what you call big query in Excel. It can even process big data, but it is structured. But I think, as you have explained, is that a data scientist uses modern ways to deal with data, and especially by use of machine learning and other modern approaches, as compared to statisticians who use very archaic, that's old kind of um, classical statistical tools and so on. So that is the main difference between the two. So maybe quickly, I just want to start from where we started on Thursday. We looked at data science predicting the future, and the basis of this was from business intelligence. Business intelligence, we say that it is still part of data science, but now it focuses on the past, what happens. Then a business intelligence analyst comes up with the reports. Those reports now are used to predict the future. That's where now data science predicting the future came, what we call predictive analytics. Looking into that, we saw that yes, data science predicting the future, it has the traditional methods also in it, such as linear regression is one of those traditional methods, however, still applied today. And as I say that when we are talking about traditional, it doesn't mean that it was just used in the past. Still, we are able to use it currently. Then we talked about logistic regression, we talked about clustering, we talked about factor time series, especially when you want to forecast those items that involve a time frame. Then we went further and looked at, I don't know if we looked at this. I don't think so. I think that's where we are starting today. Traditional forecasting methods, some of the real life explanations, and that's where I want to start from. And these examples are just a few. We have so many of them. You will do a lot as you do various practicals. But maybe just to give some of them, we have what we call user experience. And before even I explain further, I understand that some of you are already in the industry. And in case you are in the tech space, who can try to explain to us what user experience is? Yes, Belinda.
Hello, everyone. Sorry about earlier. From my experience, I'm not in the tech space, but I'm in the stats space, I would say. So, basically, user experience is when I would say a new product or an existing product has been around. What they do is give out a survey, can be a verbal survey, can be one for filling out, where they collect feedback on how people have interacted maybe with their product, what exactly would they improve, what would basically most times they want to see any challenges and most times areas of improvement. So that's what I know.
Okay, thank you so much for that. Yeah, basically user experience, I can say, is how customers or what you call users. Like if we are having, currently we are using Google Meet for this session, like how you are able to interact with the platform. I see nowadays you can not even raise your hand, that one has been there, but you can even give a reaction and so on. So basically, that is all how you are interacting with a certain platform and so on. So as you can see, even the images that I'm using here, you can see that an example that I have given, mostly you find out that when companies launch maybe a new product, they come up with what you call the surveys. And these surveys measure the attitudes of customers towards that product. Just a minute. Okay. So when this is being conducted, what normal happens? So you can find that the business intelligence team are able to generate some kind of dashboards by maybe doing customer segmentation. Like they are trying to group the customers maybe based on regions. Then after that, they now segment like each kind of group separate or region to extract what we call meaningful predictive coefficients. Like they are trying to now take some kind of a factor that they can use to predict the future. How will the future look like in a specific region and so on. So this one basically assists them to maybe see a way in which they can keep on adjusting the product and how the future will look like in terms of maximizing customer satisfaction and so on. Another basic application of this predictive analytics is what we call sales forecasting. So this one mostly when we are talking about time series, is mostly used in this sales forecasting. Forecasting is almost, it's like trying to foresee what the future looks like. And mostly, for instance, if you have a sales data and you gather this data to a certain date, so as a data scientist, what you want to know is like what likely is going to happen in the next sales period or the year ahead and so on. So you are trying just to apply some kind of mathematical and statistical models, and you try to run multiple trials. So these trials, or what we call simulations, will provide an analyst with how the future will look like. So when you see now that you are trying to run these different scenarios or trials, you are able to make better predictions and maybe implement adequate future strategies. So again, nowadays we do have what you call HR analytics. Like I think one of the guys whom will be training you also in some of the units is a data scientist, but in HR they do like they try to predict how the future will look like in terms of workload. uh, so that one basically assists the company to arrange and be able to organize their staff in order to meet, maybe in case there will be any shortfall in the future and so on, they are able to look into that. So the next question is, who uses traditional forecasting? So the main person who uses this traditional forecasting as well is a data scientist. And basically, when you're talking about data scientists, mostly they focus more on machine learning. But you find out that a lot of the work will come from one methodology to the other. I think even last week when we are doing on Friday, when we are doing the community learning project on sales forecasting using machine learning, I saw some of you were there. So we are trying to predict how it looks like the one of the Walmart data set that we are using to predict how the sales will be using machine learning. So basically, when we find like the data analysts, what they do, the data analyst will just prepare advanced types of analysis that explain the patterns in the data that have already emerged. And of course, for them, they overlook the basic parts of predictive analytics. But a data scientist, mostly they focus on the predictive part of it, like how the future will look like, what should be done, and so on. So we have seen the traditional methods, and all those traditional methods also, they are still part of machine learning. But now, we need now to define what machine learning is. I think this is another thing that you have come across severally. I can define machine learning, like the definition given for machine learning is the state-of-the-art approach to data science. And maybe the main advantage of this machine learning as compared to traditional data science techniques is that it, like machine learning, it has what you call algorithms. Algorithms are like some kind of techniques, like a formula that performs a specific part, like tasks and so on. As defined here, for instance, they are saying that there are directions that a computer uses to find a model that fits the data as well as possible. So like if you are in the community learning last Friday, you see we applied 3 models. One was giving us an accuracy, I think, of 60, then the two, another one was giving about 90, then 95% on the same data set. So those algorithms are able to run and find the most suitable one for the data. So the only difference, that the main difference we are having between what you call machine learning and traditional data science methods is that we do not give the computer instructions on how to find the sort dependence. Like what it does, the algorithm uses directions to learn on its own and to find that model better. So what happens, for instance, when you're having your data, we do have the training data set and what you call test data set. Like you are having your data, the same data set, but there's a way we do split. In what, like we split, mostly you find out that the training data set, we take 80%. Then the test data set, we take 20%. So after you train your model, then you test and see the accuracy for both training data set and test data set are almost the same. Now you deploy your model for production. So whenever data is coming, this now model keeps on learning itself and becoming much robust or much better, and the accuracy keeps on improving. Like the more the data, the more robust your model will be. It keeps on improving on itself. That's the beauty about the machine learning, like the modern machine learning methods and so on. So we see that unlike in traditional data science, that we say that mostly is being used by these the statisticians that time, human involvement is minimized in machine learning. So when you will be looking at what you call deep learning algorithms, they are so complicated, of course. Like human beings cannot, sometimes you cannot understand what is happening inside the model. But what happens, let me give you an example. Like in CAN, there's what you call, like you are trying to do image detection. To see for yourself, this model, you are able to train, like Collins takes a picture, the first picture, and labels it as Collins. Then the next time Collins takes the same, it is able to recognize that this is Collins. But when maybe another person, maybe Caleb or Chris, comes and takes the same photo, the model is able to reject. You see, you cannot really understand sometimes what is happening. But in case you have mathematical background, you come from a mathematical background, you find out that there is a lot of what you call linear equations. For those who did mathematics, there is a lot of calculus behind the scenes. So the basis of machine learning is mathematics, but it doesn't mean that you need that the mathematics for you to proceed. That's why we are saying that machine learning, especially deep learning algorithms, are so complicated that humans cannot genuinely understand what is happening inside the model. So maybe I can explain machine learning algorithms. So when you are talking about a machine learning algorithms, we are talking like a trial and error process. But the beauty about it is that each consecutive trial is at least as good as the previous one. That's why we say that these models, when you are implementing machine learning models in your companies, it does not mean that now all your problems have been solved. These models are not 100% accurate. Even for those who have interacted with Chat GPT, you see that sometimes it cannot give you what you need. So it keeps on learning as different users are asking various questions. The model now keeps on learning and improving. So you find out that sometimes you normally we recommend when you get 80% and above, I think that model we can say it is a bit good, but we normally go with 95% for business. If you get an accuracy of 95%, I think that's a very good model. But for medical research and whatever, it is normally 99. I think 99.5% there for your model to be considered to be more accurate. So for this model to learn better, it has to go through hundreds of trial and error, with the frequency of errors decreasing throughout. So again, I know you are not all of you are there in the community learning. There was, when we are trying to run the model, there was where we try to put the number of error, like the number of trials we want and we indicated about 40. So this model is able to run 40 times, like until it gets the more accurate in your data and so on. So this is what we call now training. Once the training is complete, what is happening is that the machine will be able to apply the complex computational model that it has learned to novel data, still to results of highly reliable predictions. So how machine learning models, as I said, first of all, you must have, it is not a must you have ready data. We are going to see different kind of machine learning here. But for that you need ready data, first of all, you have training data, then you have test data. So if you see that the accuracy is almost the same, then you know that this model is working better. And now, when another data of almost similar type comes in, it is able to detect or to achieve the set objective of it. So, and therefore, this one leads us to three major types of machine learning. One, we have what we call supervised learning, then we have unsupervised learning, then reinforcement learning. And I want us to start from what we call supervised learning. And it is better if you understand the theory part. I know that you will learn all of it practical, and the trainer by that time who will be taking you through will again define what it involves. But the earlier you get it, the better for you when you start the machine learning units. So one thing about supervised learning is that it uses what we call labeled data. That's one thing about supervised learning. So mostly is that the machine will get data that is associated with a correct answer, and if the machine's performance does not get the correct answer, an optimization algorithm adjusts the process and the computer does another trial. I want to give you an example. Again, I want to go to eKYC, whereby the banking industry, I think the fintech ecosystem across various African countries has really improved. And allow me to use that example because we are all, most of us are consumers of these products. What is happening today, if for instance a specific maybe bank introduces a digital product, we have that onboarding process whereby maybe you are told, first of all, they start maybe scan your identity document, then after that take a selfie of yourself. So sometimes it keeps on failing and you keep on trying until it peaks. There's that level of accuracy we do calibrate behind, like what we need. Maybe if Colin's identity document and selfie match, maybe we take 80% or 50%, then we accept and so on. That's why sometimes you are told move to where you have a lot of light or and so on. So that is supervised learning. So these are just some examples. I don't want to go into the technicalities for now. Then we have what we call unsupervised learning. So unsupervised learning works. Yes, Belinda.
I'm sorry about that. Sorry for interrupting. I just wanted to ask, in that example that you've given us for the KYC, where someone has to take a picture, in that situation, what would be the labeled data?
Okay, thank you. So what happens? Uh, like if you want to identify someone, the label data, let me say you have your image, the first data set here, they normally tell you maybe to scan a copy of your identity document. Then that one is stored in the system. And before that, first of all, they do ask you about your name, ID number, and so on. So when you scan now a copy of identity document, that one becomes labeled as Belinda. Then after that, now when you take a selfie, it is able to recognize at a certain level. It depends with what level of the threshold that the data scientists in that organization are set for it to be accepted as accurate and so on. So when now you take a selfie, it is able to recognize that this person is Belinda. So that so what normal happens is that, for instance, you have taken another person's identity, yes, document, but when you come to a selfie, it totally fails. So the label data in that case, it depends with whatever comes first. Like if you start with a selfie, the selfie becomes the label data as Belinda. If you start with identity, an image of your identity document, that one becomes the label data. So it depends with whichever comes first, and that one becomes the label data. I don't know if that is okay, Belinda. And also, let me explain, because I have used some images here. I did not do, this was intentional. Like we have a cat here. So I can train my model to identify if this is a cat or no. So I take the image of the cat and label it as cat. The next time I take the same image, it is able to tell me if it is a cat or not. So that is entails supervised learning, and mostly it works when the data is labeled. Now going to unsupervised learning. This one mostly when you are dealing with big data, or you have you are pressurized for resources to label the data, or the data scientists do not know what the labels are, all and so on. So you now come to unsupervised. So basically, unsupervised, you are dealing with big data, and secondly, unlabeled data set. So what happens is that you are just trying to give the machine unlabeled data and ask it to extract insights from it. So mostly this one, you find out that the data can be divided into maybe various categories, like they can be clustered in terms of clustering, like the machine itself is able maybe to cluster these customers and say customers who come up with this behavior can be put in the same group. Customers who can come up with this. So that's like clustering. It is able to group certain elements together without you telling the machine what to do. So that is mostly what unsupervised learning does. And this unsupervised learning is so effective in discovering patterns in data, and especially things that humans like we have those patterns that when you use the traditional analysis techniques, it is not easy to do so. So that's now, I think you are trying to connect something here if you have been very keen. You see this one, for instance, as supervised learning, like you have data, you are not sure about what this data is going to give you. but you are just throwing it away in the machine, and it is able to give you some insights itself. There's a summary somewhere after the last slide on reinforcement learning that I'm going to show to you that differentiate the three kind of machine learning easily. So the last one is reinforcement learning. So when you are talking about reinforcement learning, you are interested more on performance instead of accuracy. So for instance, whenever the machine performs better than it has before, it receives a reward. But if it performs suboptimally, the optimization algorithms does not adjust the computation. For instance, there's an example here that I have used. Let me just take you through. So let us think of a puppy learning some kind of commands. If it follows the command, it gets a treat, right? And if it doesn't follow the command, the treat does not come. So, but now what we know is because the treats are tasty, it means the dog will gradually improve in the following commands. And that said, instead of minimizing an error, what reinforcement does, it maximizes a reward. And this reinforcement learning, mostly we use them in case you like watching some kind of movies and so on. When you finish watching maybe one video, you are being recommended another one. Mostly it uses reinforcement learning techniques. But let us see a summary. I had a summary somewhere. Yeah, this one. I don't know if it is very clear to you. So we are having machine learning here. Then we have supervised learning. We have unsupervised learning. Then we are having reinforcement. Reinforcement. We are having reinforcement learning. So under supervised learning, one thing you need to know is that it works with labeled data. Under unsupervised learning, it works with data that's not unlabeled. When you go to learning, mostly we are talking about the action. As we are talking about the step and action. So under supervised learning again, we are talking about classification problems. Like, and one of the example, you will learn logistic regression. I explained a bit. We do have what called naive Bayes classifier. I want to give an example on this. Like this one mostly we use in what called market basket analysis. Like what's a probability that maybe when men go to the supermarket, let us say maybe after job, maybe you have a small baby in the house, then after job, you pass through the supermarket. So when you purchase maybe Pampers, you also purchase maybe a bottle of beer and so on. So mostly naive Bayes is used in what called market basket analysis. You are trying to know like which items do clients like purchasing together. That basically will assist you to do that. So example, for instance, classification, we are talking email spam detection, like you are able to detect if this email is a spam email or not. Then we have speech recognition, like then apart from email spam detection and speech recognition, the most common one like fraud detection, if a transaction is fraudulent in finance and so on. under classification, also under supervised learning, even regression, linear, ordinary squares, and all these are part of supervised learning, and it deals with labeled data. An example under regression, like stock market prediction, like you want to predict how the stock market will perform, rainfall prediction to look into the future, and so on. Then when we go to unsupervised learning, we say that it deals with data that is not labeled. And when the data is not labeled, mostly supervised learning deals with what called clustering problems. One of them, we are talking about k-means, clustering, k-median. I'm not going to go so much into the details, but I'm going to focus into examples because we'll go through them practically. But example of unsupervised learning is identifying fake news, like fake news detection. This is nowadays we have a lot of fake news, so machine learning has been able to solve this issue to reduce spread of fake news. We have document analysis, and again we have what we call association analysis. We have association analysis here. I think I gave a wrong sorry for that. I gave a wrong on naive bias. Naive bias mostly it talks about the probability, like this what called conditional probability. For something to happen, another thing has to happen. That's what naive bias gives, but it is not part of market basket analysis, because market basket analysis, and sorry for that, we are talking about a priori and Eckert, like they are mostly used. But when you are talking naive bias classification, you are talking about what called conditional probability. And maybe in case you went through a statistic class, you are able to meet across, like for this to happen, another thing had to happen. Then there's also what called dimensional reduction. And I don't know if I mentioned something on principal component analysis, and I don't know if I mentioned, but mostly when you look at analysis of written text and DNA, microarray data, and so on, we are talking of unsupervised learning. Then we have what called reinforcement learning. So these are some of them, like hybrid policy optimization. And examples here, we are talking about multi-agent systems, motion planning, and navigation. But the most common example of reinforcement learning is recommender systems. Like you are building recommender systems that try to connect some kind of relationship. For instance, today, I know most people nowadays watch movies on Netflix, and even without going further into Netflix, let us say even YouTube. So when you watch something on YouTube nowadays, you are recommended, like based on your behavior, it is able to learn your behavior and recommend to you what you think maybe works. Like based on your behavior, your pattern, the recommender system is able to analyze your pattern, what you like, and recommend almost similar content to you. And this one can be used even by organizations, the insurance companies, the financial, and so on, to be able to come up with such kind of systems. So you see now how machine learning looks like it is more wide, and whatever is covered in machine learning, a normal data analyst cannot handle. That's why now differentiate a data analyst with a data scientist. But a business analytics expert covers now some of the classification problem, especially the prediction part of it. But when you go to more advanced, especially on unsupervised learning and reinforcement learning, find out that the data scientists have more knowledge with regards to this. So before we look at some more use cases, this is a technical area that I don't want to rush so much. I just want to give you an opportunity to ask maybe 1-2 questions, then we go for a break before we come back. Any question that you saw maybe it was necessary? Yes, Hein?
When we talked about the reinforcement learning, on the slides it mentions in point 1, obviously we are focusing on performance, and in point 2 we say whenever the performance is better, it gets rewarded. Now, how do we measure performance? Is that a thing of time, or is performance based on accuracy? Yeah.
Okay, thank you. The performance is based on accuracy, not time. Because as we say that these machine learning models, they have what you call algorithms, and these algorithms become better, more better when we have several kind of trials and so on. So the performance is based on how accurate it will be, as compared to, it can't be like in terms of time. Yes, we say that, as we say that the main thing is performance instead of accuracy. Yes, but we see that whenever it performs better than it has before, it receives a reward. But you see, for it also to perform better, it means we have some kind of simulations that have happened that improves this kind of performance, not just based on a matter of time. There's another question. Let me check. There's a question somewhere. Just a minute. Okay, let me answer Mary's before I give to Cyprian. So it is not you who selects these, it is the algorithm. Like an algorithm is some kind of set instructions that guides the machine on how it performs. What you can only do, like after you train your model, but not in reinforcement learning, especially when we come to supervised and unsupervised, you can now come up with what's called threshold. In machine learning, you will learn on how to evaluate your model performance. So during that evaluation of your model performance is when now you set the threshold of what you want and what you don't want. But the reward, it does not come from you. Like it is something that comes from the model. After now you evaluate the performance, we have various ways in which the evaluation of the performance of the model happens. That is when now you set your threshold. Like at this point, you say, I want it to be like this at this point. So whenever there's data and it runs, of course, now when it passes through that threshold that you have set, is when a certain action happens. So maybe Cyprian before Kenneth.
Hi, Xavier. Since you have answered me, I had the same question with Mary. I was trying to understand what types of reward does the machine receive. So yeah.
Okay, thank you for that.
Okay.
Okay. Kennedy?
Thank you, Xavier. I wanted to ask, in a scenario like you are trying to log in into your email, then maybe you have missed some password. Then you are told to either click on images of traffic lights or maybe a bicycle within a picture of it. Where do we classify such ones?
Okay, thank you so much. That one we can classify as part of supervised learning, but it is not such. That one can even be done by a normal programming software engineering concept as compared even to more machine learning. But still we can classify it under supervised learning. But in fact, yesterday, if I'm not wrong, I saw a certain, I don't know if it, I don't know where I came across it, but in the UK, they are implementing some kind of advanced AI, like machine learning cameras, something like that in case you offend like the traffic offenses, you are able, what I saw about it, like those cameras are able even to know the kind of to detect your image as a driver. I don't know if there's anyone who came across something like that, in case you are able to read it. But in case I find it again, I'll reshare. So that is also part of supervised learning. But you will learn more practical as you go. I think from unit number about 7 to the end now, it is all about machine learning. Any other question before we go for a break? Okay, so we are going to come and look at some of the applications of machine learning. Of course, you have mentioned others here, but I have more use cases here. Then I think after that, we will continue. I don't know, Chris, you can ask your question maybe before we go, so that you don't forget it. Yes, Chris, I see your hand is up. Okay, maybe you can ask when we come back. So let us go for a 15 minutes break. We come back at 9:15 East Africa. That's Nairobi time. I think after that we can proceed. So Chris, maybe you can ask your question at that time, in case you are not in a position to speak. There is a question, though it is not very clear to me. That's from sorry. That's from Chris.
Yes, I was asking, what is the machine language that is in VR, the virtual reality machines?
Okay, like what's the machine learning, or like the type of machine learning?
Yes.
I don't know if just a minute. Like you are talking about when you are talking about the what do we call the classification of machine learning models and so on.
Absolutely.
Yeah, that's a part of supervised learning. Hello.
Yeah, yeah. I hear you very well.
Okay, yeah. It is part of
The virtual
supervised.
reality is supervised, huh?
Yeah, that's supervised learning.
Okay, thank you.
Okay. Sorry. So I think if you are back, we can have a look at other use cases of machine learning. I think this one I have used severally. The one on fraud detection, like when you are talking about fraud detection, and especially as used by banks. So what can happen here is that they take past data, then they label the transactions as either legitimate or fraudulent. Then after that, you train the model to detect any kind of fraudulent activity. So what happens now when these models detect even the slightest probability of theft, they flag the transactions and of course prevent the fraud in real time. Like maybe that transaction is flagged to go for further kind of investigation and so on. That's what happens in fraud detection, especially in financial sector. Then in terms of client retention, maybe what organizations can do, you are trying to try to know the kind of customers that might purchase items from you. So it means that what can happen here is that the stores can offer discount and a personal touch in an efficient way by minimizing marketing costs and maximizing profit. So, for instance, Google and Amazon use these strategies. So, what it means here, instead of just giving everyone a discount, and maybe customers who might not be interested in the product, so based on past behavior, when you are interacting with these kind of platforms, they are able to. Sorry, maybe you can mute. That's Cyprian. Sorry.
Apologies.
Okay, no worries. Yeah. Okay, I was explaining a point on client retention. You see, these companies collect a lot of data, especially big data, and they already know some kind of user behavior, like even in terms of the type of a phone that you are using. If a customer comes with such kind of a phone model, maybe they are good buyers of such kind of products and so on. So when they are going now to offer discount, maybe they can offer discounts to those specific products that are geared towards a specific customer base and so on, so that they don't offer just discount for everyone. They are trying to maximize on specific kind of customers to retain them and so on. Then maybe the last thing here that we can look into, who uses machine learning? Who uses machine learning? So as we said, a data scientist is deeply involved in designing machine learning algorithms, but there's another person here who focuses on machine learning alone. As I said during one of our classes, is that it depends with your organization. Some companies have a lot of money that they can hire a lot of people, but others do not have that luxury to just have a data scientist alone who handles everything, then a machine learning engineer alone. We have a data engineer, a data analyst, in most organizations, you are just hired as a data scientist, you do the end-to-end process. But others might like to specialize and have maybe a machine learning engineer alone. This person specializes, especially is just a specialist in this area, and they look for ways to apply state-of-the-art computational models developed in the field of machine learning into solving problems such as business tasks, data science tasks, computer vision, self-driving cars, robotics, and so on. So the role of this person is just to do machine learning tasks alone. Like when it comes to other part of data science processes, like data engineering, maybe data pre-processing, of course, it is part of data engineering, and so on, they are not involved. For them, their work is just to start from building machine learning models and maybe deploying alone. That's the work of a machine learning engineer. So I don't want to introduce artificial intelligence and data governance in today's class. As I said that it has been a very technical class, but maybe we can have just a quick recap. I think we started on who uses traditional forecasting, but let me start from machine learning. So we define machine learning as a modern approach, what we call a state-of-the-art approach to data science. And I think what has come up very clearly for in this class, even now as you are trying to differentiate different kind of difference between maybe a data analyst, a machine learning engineer, data scientist, and so on, it is now becoming maybe more clear, if I can say. And as you have said that machine learning have algorithms, like this is something you can't see, like it is something very difficult to explain, but what we have talked about these algorithms is that they assist you to achieve a specific machine learning task without a hassle, like without a lot of programming that is involved. And another thing we have talked about algorithms is that they work based on trial and error. And the more trial and errors, the more it becomes accurate. After that, we have looked at different kind of machine learning, supervised learning. We said it works mostly with labeled data. Then we talked about unsupervised learning and labeled data. And we looked into reinforcement learning, where the focus is more on performance instead of accuracy. Then we have looked at, we had a summary here on various machine learning categories. After that, we have looked at some use cases, two of them, like fraud detection, especially in the financial ecosystem. What happens? You have said that, first of all, they must have some kind of data, label it as fraudulent or not. Then after that, they have to train, to test, and deploy this model so that in case any other transaction comes that is fraudulent, they flag it off for maybe further investigation. We have talked about client retention, how bigger organizations nowadays, especially in terms of discount, instead of giving each and every person a discount, based on the data, they know they are able to segment their customers and know which kind of customers are given these. Then we have talked about who uses machine learning. Of course, you have said like a data scientist, the main person involved in designing these machine learning algorithms. But now we have a specialist that deals with this. Like you have data, someone else does some kind of data pre-processing, does what you call exploratory data analysis, like you are trying to visualize your data. Then a machine learning engineer picks from building machine learning models going forward alone. So that is the focus, I think. Tomorrow we will start from AI, then data governance. This is an interesting topic. Then, of course, languages as we move forward. So, any questions? As I'm waiting for any questions, the recording I'll share as usual before I'll share. Yes, Belinda.
Good evening, everyone. So, this is not really on what we have studied today. I just wanted to ask if there is I can see a lot of machine learning and let me say data programming. So, what I wanted to know is it in your experience, do you suggest or do you recommend any of us to maybe take on like a little bit of software learning, like software engineering, maybe?
Okay, thank you so much. Data science is totally different from software engineering, unless if you want to work as a data science developer, like you know both software engineering and data science. But what we normally do, like if I build my machine learning models, we have the IT team, the software engineers that they build these applications and share what you call APIs. So those APIs now are able to interact with whatever the software engineers have done. So it is totally different from software engineering, if I can say. So these people work together. However, I can say if I'm a data scientist and a software engineer, like it is an advantage. But if I'm working as a data scientist alone, like my case, I work with the software engineers. When you build your models, you train, you develop what they come up with what you call APIs now to link maybe the mobile application that you are using for a certain purpose with now the model that you have built in case you are working on a machine learning model. So I don't know, Belinda, if that is clear. But what I can say, if you have time to learn software engineering, it is also okay. But there's no any relationship here between data science and software engineering, despite the fact that they are all tech fields, but it is totally different. Okay, thank you. Any other question? On the issue of model deployment, if you have looked at your curriculum well, there's that part that you'll be trained on how to deploy your model for commercialization. And also you will be trained on API, the idea of APIs. If you have gone through the curriculum well that I shared during the first day. Yes, Cyprian?
Okay, maybe let's say I've been exposed to maybe a number of platforms, perhaps maybe CRM, if you have an idea about it. So is CRM a database or a system?
CRM is a system. It is a web-based application. The one that we use to interact with the customers, like to manage calls, chat, sales, and so on. So it is a system.
Okay, maybe one more. So what can we classify? Maybe when we are trying to log into some platforms, maybe our bank detail, there's a certain step where we are called to identify if we are not robots. We are to click to identify if we are not robots, or we are to type in some words so that they can identify if we are not robots. So where can we classify that?
Okay, thank you so much. I think that question was again asked, but that one I can say it is a normal programming technique. It's not more of data science, but if you can allow me to confirm further, just to be sure, because that is where mostly data science comes in when we are talking about image detection and so on. But where you are just told to confirm if you are not a robot and so on, it is a normal programming kind of technique. But allow me just to confirm further and give more explanation tomorrow. I have just noted it down. Is that okay, Cyprian?
That's okay.
Yeah. Yes, Kennedy?
Okay, I wanted to ask for starters who haven't had any background of data, being from the analysis and the basics. Will we be able to have those experiences in terms of practicals, so we can be able to do the analysis for the basic data that we generate?
Yeah, this is the only unit that we are doing theory. The rest of the courses, if you are for certified data scientist, the next 15 units are all practicals. Of course, like the next unit, I'm the one who will be training you again. It will be still basics. The R essentials is basics. Of course, you need to know some items like the interface and so on. When you go to Python, there's one unit of Python which is basic. Then now, like it starts to build up as you go further. So everything, it will be from basics with simple data as we move to more intermediate and of course advanced level. So that one is covered, Kennedy. Don't worry. You still have about 7 months to go. Is that okay, Kennedy?
Yes, sure. Thank you.
Okay, thank you. Any other question or concern? Okay, thank you, team, for joining today's session. I'll be sharing the recording so that you can have time maybe to go through it. Tomorrow we will start on, I think it was AI, introduction to artificial intelligence. Then we look at data governance. So before we look at data governance, maybe you go and try and research in your various jurisdictions like countries, the issues of data privacy and so on, so that we can have a very high level discussion tomorrow on data governance. Yeah. Yes, Mr. Michael.
Good evening, everyone.
Good
I
evening.
just wanted to inquire. I saw the link that was sent on Friday regarding our Friday lesson, yet I was told our lessons are from Monday to Thursday. So, and you mentioned during the lesson that there are some of us who had joined that lesson. So, are we supposed to join any link that is sent on the group, or we are a mixed group within the WhatsApp group?
Okay, thank you. So, we do have what you call community. This involves our graduates, students who are still ongoing, various trainers, and anyone who is interested to keep on learning.
Okay.
So in that community learning, we tackle various projects, and anyone can volunteer to take guys through a certain concepts. Like if we start a project, we do an end-to-end project. Like the current one that we started by data cleaning. We are building a machine learning model for sales forecasting. We
Yes.
started with importing the data, cleaning the data. We did what we call exploratory data analysis. Last Friday, we were building the machine learning models. Then we will complete this Friday by deploying the model into production. The main purpose is to enrich your portfolio, like so that you know this is a practical course and you need to keep on keep on maybe practicing to be more and more perfect. So it is not a must to attend the community learning, but if you have time, we advise that you can be joining.
Okay, thank you. Thank you so much, sir.
Okay. Thank you, guys. I think we can end here for today. So have a good night. We meet tomorrow, same time.